Okay, so today we're gonna dive deep, and I mean really deep. We're talking about a piece of tech that could totally flip the script on how we see our own planet. A new kind of tool for exploring that massive unknown world just beneath the waves. It's a wild fact to think about. 95% of our oceans are basically a complete mystery. We just haven't seen them. The deep sea is an incredibly tough and expensive place to work. But what if the answer isn't some giant billion-dollar submarine? What if it's an army of tiny, smart robots, all working together? Well, say hello to the hero of our story today, the benthic node. Look at this thing. It's a 15-centimeter sphere. We're talking about the size of a grapefruit here, but it is absolutely packed with some of the most advanced tech you can imagine. The whole idea was to make it cheap, make it tough, and make it unbelievably smart. So how in the world do you build a tiny robot that can survive one of the most brutal environments on Earth? Well, it all comes down to some really, really clever engineering, starting with the very material it's made of. This little chart here shows you the problem they were trying to solve. Aluminum, it just corrodes in seawater. Stainless steel, way too heavy. But this specific titanium alloy, T6Al4V, well, that's the Goldilocks solution. It has this incredible strength-to-weight ratio, and it basically laughs at saltwater corrosion. So by 3D printing the shell, the engineers got something that's both super light and ridiculously strong. Okay, so what about getting around? The node doesn't use noisy, power-guzzling propellers. Nope. Instead, it has this thing called a buoyancy engine. It works by pumping a tiny bit of oil to an external bladder, which makes it a little bigger and lets it float up. To sink, it just pulls that oil right back in. This means it can glide completely silently for months at a time, just sipping power. And all that brilliant engineering means the benthic node can operate at a pretty impressive 500 meters deep. That spherical shape is absolutely key, by the way. It distributes that crushing water pressure perfectly and evenly across the whole surface, so there are no weak spots. And here is the real game changer. After a few days of surveying down in the dark, the node just glides up to the surface. The solar panels on its top half completely recharge its battery. This cycle, dive, surface, recharge, gives it almost infinite endurance. It solves the single biggest problem for underwater robots, running out of juice. But the real magic of the benthic node isn't just its tough little body. It's the brain. The way it actually perceives and understands the world around it, well, it's a whole new approach, kind of inspired by how bats navigate using sound. So think about it like this. If you're trying to understand a landscape, you need to see the big picture, the shape of the whole forest. But you also need to see the individual trees and even the texture of the leaves on a single branch. Traditional sonar, it's usually stuck seeing just one of those things at a time. The benthic node needed a way to see all three all at once. The solution is this AI framework they call the Universal Signal Decomposition Framework, or USDF. The easiest way to think about it is like a prism for sound. It takes a really complex sonar echo that bounces back and breaks it down into its simpler underlying frequencies. And each of those simple waves tells a different piece of the story. And this table just illustrates it perfectly. The AI basically translates different sonar frequencies into different scales. The low frequencies, those slow, long waves, they're for seeing the forest, the big long-range map of the seafloor. The mid-frequencies are for spotting the trees, things like obstacles or even other nodes. And then those high frequencies, they give you a super high-res image of the leaves, all the fine textures and little details on the seabed. Okay, so now we get how one of these nodes is built and how it thinks. Let's zoom out. Because the real power here isn't in a single robot, but in hundreds of them, all working together as a team. And this is where Project Abyssal comes in. Look, one benthic node is smart. It can gather data, but a coordinated swarm? A swarm is brilliant. It can create a complete, high-resolution map of a huge area. They actually talk to each other using sound, sharing what they find and coordinating their search patterns to be as efficient as possible. So how do you manage all that chaos? Well, the swarm uses this really elegant 4-level system. At the self level, each node is just worried about itself, keeping its battery charged, staying safe. At the local level, it's talking to its neighbors, mostly to avoid bumping into them. Then, at the collective level, the whole swarm works together to achieve the bigger mission, like mapping an entire area. And finally, at the top, the human level lets operators give big picture commands like, hey, go check out that canyon over there. So what's the end result? What's the ultimate impact of all this incredible technology? It really boils down to one simple, absolutely revolutionary thing: cost. Just look at this chart. To map 1 square kilometer of the ocean floor with a traditional survey ship, you're looking at about $145. The Benthic node swarm, it can do the exact same job for $8.69. I mean, the difference is just staggering. That's a 94% cost reduction. And this doesn't just make ocean mapping a little cheaper. This makes mapping the entire ocean economically possible for the very first time in human history. It completely changes the game. We started this whole thing by talking about how little we really know about our own planet. For centuries, the deep ocean has been this huge mystery, right? A final frontier that seemed almost impossible to ever fully explore. But with armies of these tiny, intelligent robots, that frontier is suddenly wide open. A complete map of our world's oceans isn't a sci-fi dream anymore. It's an engineering project we can actually do. And that just leaves us with one absolutely thrilling question. What are we going to find down there? What new ecosystems, new wonders, and new secrets are waiting for us in the deep?